A lot of words in this one. Just take it one piece at a time. Let's see what we get. A school district is forming a committee to discuss plans for the construction of a new high school. Of those invited to join the committee, 15% are parents of students, 45% are teachers from the current high school, 25% are school and district administrators, and the remaining 6 individuals are students. Well, right there, that's weird, right? That should stand out to you. Every other group was given as a percent. This is not. So that seems strange. I'm probably going to focus on that. How many more teachers were invited to join the committee than school and district administrators? So teachers are going to be a percentage, 45%, and district administrators, I saw that before, 25%. So if you put 20 here, come on, you got to know that that's wrong, right? I mean, you can't just subtract 45 and 20 and 25 and get 20 and just be like, yeah, that's it, right? That's a percentage. What we're trying to do is talk about a raw number of people, right? So that's really the ultimate thing about this question and about percentages in general that's so difficult is that it's kind of like 2 different units, right? We have kind of the raw numbers, the number of each type of person that we're talking about here. But we also have that as a percentage, which is kind of like a conversion to think about things in a very standardized way, right? It's basically like we're taking that fraction that each grouping represents, and then for whatever reason, we've decided that 100%, 100 as the denominator is a good standard way to think about things. So that's what a percentage is ultimately. So what we need to do is we need to understand that fraction, right? So we need to say, okay, what do these 6 individuals represent as a part of the whole? Because I don't know the whole number. I don't know the percentage of those students either, but I need to get it somehow because it's kind of like if I'm thinking about my open formulas, I know I'm using this one. I'm not talking about percent increase or decrease at any point, right? It does say how many more teachers at the end here, but notice that's not a percent change. They're not changing by a certain percent. That's just a difference, right? So just because the fact that the word more is there doesn't mean it's a percent increase. The percent itself is not increasing or decreasing. But anyway, I know I've got to use the basic open formula. I know that I don't know the original number of people, right? I don't know how many people are in this committee. I don't have a percentage for these 6 individuals, so I don't know the P, but I do know that that 6 is a certain percent of the whole. So the reason I kept the P as a P is I actually do know it. I just got to work for it, right? Because I know that all the other percentages, right? And the remaining 6, meaning those 4 groups is everybody. And the good thing about a percent is that 100 is everybody, right? 100% is everyone. So we know that there's 100% minus the 15% of parents, minus the 45% of teachers, and minus the 25% of administrators. And whatever's left over, that's going to be the 6 students. But we want to get that as a percentage so we can compare. So I'm just going to subtract, right? So 100, I'm going to do it in my regular calculator, 100 minus 15 minus 45 minus 25 is 15% left over. So this is again like unit conversion, right? This is kind of like centimeters and inches or something, right? Like we have a way of kind of moving between these 2 units. The percentage is kind of one unit, and then the actual number of people is another unit. So that's what we're really doing. That's what the open formulas do overall. But now we understand that there is some number of people total, and 15% of that number gives me the students, right? 15% of the committee is students, so 6 students. What is that starting number, right? So now we can solve for it, divide both sides by 0.15. Again, regular calculator does the job. 6 divided by 0.15 is 40. So there are 40 people on the committee. Now, let's just go to what they asked, right? How many more teachers than administrators? So teachers is going to be 45%. So what is 45% of 40, right? So where can I do that? Let's do that down here. So 45% of 40, this is kind of just a normal open formula. That's going to give us the teachers, right? So that's 40 times 0.45 is 18. That's 18. And 25% are administrators. So 40, 25% of those are administrators. So that's just 10, but I'm entering it already anyway. So let's just be sure. Yep. And then they want the difference. So 18 minus 10 is 8. There you go. A lot of steps in this question, right? This has got more going on than the typical percentage question, but if you really think about the math, what do we really do? Just a little subtraction, some division, used a calculator, right? The math isn't really hard. The problem is people are just so overwhelmed by everything they're given and they don't understand what a percentage is really. They just kind of have some buttons that they push on a calculator when they're asked about one. But a percentage is just a kind of standardized way of turning whatever fraction we're dealing with into a fraction that just everyone understands, right? Because it's a denominator of 100. So that's really what we're doing here. And basically, like I said, it's kind of like a unit conversion. You're converting these groups that we got as percents, one kind of unit, into this other number, this kind of raw number. And that's the relationship between those two units that really matters. The open formulas are kind of like our conversion between those two things. And it really matters here. So I would just keep an eye out for a question like this. This could easily come up again. This is not that difficult. This is just basic percentages in a way, but in a way that involves a lot of steps and can really overwhelm people. So hopefully just seeing this one, even if you had trouble with it this time, will help you in the future if you see something else like it.